Okay. In a nutshell, energy is the ability to do work, which means to say, do not think of it as similar with thermal energy, with chemical energy, with light energy, and so on. Okay? The energy that we are going to deal with is concerned about position and motion of an object. If that is the case, energy can be simply defined as the ability to do work, which means that work and energy are interconnected with each other. Since energy is the ability to do work, we will focus on this type of energy. As mentioned a while ago, we will be tackling energy different from the forms of energies that we know. Mechanical energy, this is energy which is stored or in motion. So we have two general types of mechanical energy. The first one is kinetic energy. This is not new to you. Perhaps to some or to majority of you, this is just a recall. Not that familiar, but you know this is existing. This is energy in motion. And the second one is potential energy. Okay. Let us discuss deeply these two types. Okay. Kinetic energy is generally based on the velocity of the object. Since it is defined as energy in motion, you'll have to consider or you have to look into its change of position. Definitely, if it is not moving, the particle or the rigid body is not moving, kinetic energy is zero. On the other hand, potential energy, it's the energy of an object stored as a result of its position. As a result of its position. If the potential energy is a result of its position, it is also known as GPE or gravitational potential energy. If the stored energy is a result of its elastic property, that potential energy is known as EPE. Okay? Gravitational potential energy is concerned more of its position, vertical position. Or in other words, height is the main consideration. Okay? And for elastic potential energy, it is concerned with elastic constant or property. Okay? So these are the two types of potential energy. That's energy stored. If the object is resting or position relative to the ground, you are talking about gravitational potential energy. However, if the stored energy is pertaining to its capacity to go to its original form, definitely it has elastic potential energy. One typical example of which is the bow and the arrow. Once the archer pulls the string and not releasing yet the arrow, it has elastic potential energy. The farther the string is pulled, the greater the amount of EPE. For GPE, the higher the position relative to the ground, the greater the GPE. Okay? So these are the two types of mechanical energy. Now, for the most 10 minutes, we'll answer or you'll answer the following question using the simulation. Later, I will attach or copy the URL in the chat box so that everyone can explore the website. But before that, please bear in mind the following questions. Using the simulation, this is the screenshot simulation. In what position is gravitational potential energy minimum? In what position is it maximum? Number 2, in what position is kinetic energy minimum? And in what position it is maximum? Then what conclusion or generalization can be made about total mechanical energy? Okay? So for the meantime, I'll be pasting this URL in the chat box. Kindly hit the link, explore it, then answer the following question. I hope you will be directed to this interface. Hit intro. And after hitting intro, place the skater on top. Then check bar graph. I repeat, if initially the skater is outside the ramp, place him on top. Then check the bar graph. If you want to check the pie chart, no problem. Okay? Then press the play in normal. You can do that. If you cannot, if you're having a hard time identifying the answer to the questions because the movement is too fast, you may click the slow motion button. Okay? So be giving you time to answer these questions. These are the questions. answers, Jacob? GP is minimum at the lowest position on the ramp, then maximum on top. Pa-heart reaction or thumbs up reaction if you have the same answer. Please. Thank you. That's correct. GP is minimum when the skater is on its lowest point relative to the ground, and maximum if it's on the highest position relative to the ground. How about number 2? Who would like to answer number 2? Thank you, Jacob. Number 2? Anyone from the girls? Sino bang matatawag rin? Mikaela? Number 2? In what position is kinetic energy minimum or maximum? Mikaela, can you hear me?
Sir?
Yeah, sure. Number 2, what's your answer for number 2? This one.
Sir, minimum po sa ano? Maximum po sa minimum po sa starting point po.
This one, on top.
Opo.
Okay, then? Maximum?
Maximum po sa lowest.
Okay. That's correct, I think. Kinetic energy is minimum on top of the ramp, and the maximum value of kinetic energy is at the lowest point of the ramp. Okay? Your answers, thank you, Mikaela. Your answers for number 1 and number 2 has a connection with number 3 question. For what generalization can be made about total mechanical energy? Who would like to answer this question? May na-disconnect. 39 na lang tayo. Anyway, what generalization can be made about total mechanical energy? Punta tayo dun sa ano. Simulation. The question is, what generalization can be made regarding total mechanical energy? This moss green bar represents the total mechanical energy throughout the position and motion of the particle or the object. The total mechanical energy is conserved or constant, di ba? And one observation can be added to that. Parang opposite yung kinetic energy at saka potential. Okay? If kinetic energy is maximum, dito maximum ang kinetic energy, dito. Dito. Di ba? Diyan. Diyan maximum ang kinetic energy, pero minimum naman ang gravitational potential energy. Di ba? Try natin i-pause. Ayan. Look at the graph. Kinetic energy maximum. Potential energy, GPE is minimum. But the total mechanical energy is just the same. However, kapag umakyat naman yan, nagbabaliktad sila. Nasa taas, gravitational potential energy is maximum at this point, pero minimum naman yung kinetic energy. But do not forget, regardless of the motion and position of the object or particle, the total mechanical energy is conserved. Total mechanical energy is conserved. Okay, let's go back with the PowerPoint presentation. I hope it's clear to you regarding GPE, kinetic energy, and total mechanical energy relationship. Okay, we continue with yan. Balikan lang natin, di ba? Sa EK, habang iniakit dun sa pabalik yun, di ba? Hindi pa binabagsak, nasigaw na si Mikaela, hindi pa binabagsak. Di ba? Akit pa lang yun, papatalikod. Hindi pa na nire-release, ano, nasigaw na. Okay? Kasi yun yung objective. To make the cart as high as possible relative to the ground because as you increase height, stored energy increases. Pag na-release na yun, that potential energy will be transformed into kinetic energy. Mas mabilis. Okay? Now, another application or valuing for regarding kinetic energy and gravitational potential energy is this. How dangerous is this? Dropping or throwing a coin on top of a tall structure. Okay? Remember that height is the main factor for stored energy or gravitational potential energy. As you increase in height, the stored energy increases. And upon releasing, that GPE will be transformed into kinetic energy. Imagine, if someone will be hit by this coin, we do not know what will happen. Definitely, it will hurt. I do not know if it will be fatal. Though in the books that I have read, the coin or anything dropped from a particular height will have its what we call terminal velocity. Hanggang doon na lang yung bilis niya. Regardless of if it's not that far or near the ground, meron na lang yung mahihit na velocity. But regardless, the terminal velocity is very fast. Okay? In that sense, it's a no-no to drop or throw something from tall structures. If someone will be hit, it will hurt. For stray bullets, it's a different thing because of aerodynamics. Diba? Kaya pag tinamaan ng bala ng barel, ay ano sa ulo, malapit-lapit ang hindi mabubuhay. Okay? It's really prohibited to take a shot not licensed or without any consent. Bawal yan sa batas. Okay? Valuing natin regarding potential energy and kinetic energy. Continuing. Okay. The mathematical side of gravitational potential energy is simply the product of the mass of the object, the acceleration due to gravity, and the height. But it is also connected with work. Remember, energy is the capacity to do work. This is a form of energy. That's why we can also equate it to work. And work is FD. Yung F na to ay yung weight ng object. That's why it's mg. Yan. Multiplying it by height, ayan. Yung D na yun, ayun na yung height niya. Ayan. Yeah, our working equation for gravitational potential energy is mgh. And the unit is still in joules. Remember, mg is a force, Newton yan, height is expressed in meter, Newton meter, a Newton meter is equivalent to a joule. Okay. Forget natin, K is minimum when the object, my connection is unstable. K is minimum when the object is at rest and located at the highest position relative to the ground. Kinetic energy is maximum if the object gained kinetic energy when it is very near to the ground. We have seen that in the simulation. Time check, 11:50. Similar with the gravitational potential energy, it has also, kinetic energy has also its mathematical definition. It's half the product of the mass of the object and the square of its velocity. A while ago in GPE, height is the defining factor. Remember, mass is constant. Acceleration due to gravity is constant as well. But in this case, the defining variable or quantity is the velocity of the object. It's directly proportional to the square of the velocity, which means that if we double the velocity, the effect on kinetic energy will be squared initially, but we'll have to divide it into 2 because that's half. Okay? So the big idea here is that velocity is the defining quantity for kinetic energy. Okay, dalawa yun. GPE and KE. What's next for us? Ayan na yan. Aside from what you have generalized, this is a more technical conclusion regarding total mechanical energy. I think I saw this from the answer of Mr. San Jose in the chat box. Okay? The conservation of mechanical energy is in the absence of friction, it's always conserved. The amount of mechanical energy remains constant. Okay? With this idea presented to us, that mechanical energy or total mechanical energy is conserved, let us apply this principle in this example. Right? We have here a loop ramp, given to us different stations, 1, 2, 3, and 4. Station 4. Let us complete first the missing values. Wag na muna itong tanong, what is the mass and velocity of the object? Ito munang missing values here. Do not be confused. This is another way, or these are other ways of expressing gravitational potential energy, kinetic energy, and total energy or mechanical energy. E sub G is gravitational potential energy. EK is kinetic energy, and E total is total mechanical energy. Okay? Let us complete the values per station or per number. Okay? So, station 1, very simple. The total mechanical energy is 200 joules. 200 joules. Siyempre, just add. Total na eh. Oh, how about station 2? Who would like to answer station 2? What's the value of EK and E total? Yes, would like to answer? Meron ba kayo idea? How do we get E sub K and E total? $11.55. Ako na. Sige, sir, ikaw na. Okay. EK is 50. E total is 200. Bakit kayo na isulat ko doon? $50 joules. Oh, kaya nyo na sagutan yung third station. What is E sub G? Nahuli na. Yung padalwa kong example, nahuli na yung concept. Nahuli ni Julian, ni Jacob, ni JL. Yes. Si Kyle din. Rhea. Correct. Oh, nakuha na yung concept. Yes, Preda. Di zero ito. Ano? Yeah. Yes. Correct. Yes. 0 joule. Ito, 200 pa din. Kaya hindi nyo kasi nasagutan yung number 2. Sabi ko sa inyo kanina eh. Apply yung concept ng total mechanical energy, conservation. Di ba hindi nagbabago yung total? Kung sa simula ay 200 na yun, puro 200 na yan lahat. With that idea, masasagutan mo yung na iba. Okay? Number 4 ay simple yung number 4. Yes. 140 na ito. 140 joules na yan. Again, total mechanical energy is conserved. Throughout or regardless of the position or motion of the particle or object, total mechanical energy is conserved and constant. That is the big idea of the conservation. Maliwanag? Okay. Tomorrow, may recorded video nga ako. May recorded video ako ng lesson natin kasunod. Okay, application itong kinetic energy, GPE, tsaka total mechanical energy. Yan. Anong mga sagot dyan, and so on. Baka ma-press ko may mga sagot na yan. Okay, that will be for tomorrow. Okay? Concerns? Questions? Anyone? Something to clarify? Maliwanag naman ang lesson? Okay. Be requesting our